A cursed ocean zone swallows ships and planes. You've heard it whispered for decades, usually with a shiver and a map. We're going to test that claim. We'll ask whether this region is unusually dangerous, what the numbers say, and why the story keeps coming back. By cursed ocean zone, people usually mean the Bermuda Triangle, a broad area roughly bounded by Miami, Bermuda, and Puerto Rico. It's a busy corner of the Atlantic that funnels traffic between the Americas, Europe, and the Caribbean. The myth endures because it flatters our taste for riddles. Vanishings make better headlines than routine explanations, and mystery sells books, documentaries, and late-night radio. First, traffic density. When hundreds of thousands of flights and sailings cross a region over many years, raw incident counts will rise even if the per-mile risk stays ordinary. That's the denominator problem. Without knowing how many trips happened safely, a list of disasters only measures attention, not danger. Next, weather. This zone sits in the path of fast-changing subtropical systems, squalls, microbursts, abrupt wind shifts, and the edges of hurricanes from late summer into fall. The Gulf Stream, a narrow, swift current, runs like a river in the sea. It steepens waves, pushes floating debris away, and can hide wreckage quickly. Low clouds and rain shafts can form in minutes. Pilots call some of these pop-up events convective cells, and they can punch a small aircraft hard enough to overwhelm older instruments. None of that is unique. The Bay of Bengal, the South China Sea, and the North Atlantic west of Ireland all host similar, sometimes worse, weather swings. Navigation matters too. Compass variation, called magnetic declination, changes across latitude and time, and pilots or mariners who forget to correct charts and headings can drift. But that's training, not a curse. The same correction applies in Alaska, the Mediterranean, and the Southern Ocean, and crews plan for it. Communication technology also sets the record. In the 1940s through the 1960s, many craft lacked today's satellite beacons, autopilots, and weather radar, which meant errors and storms could compound faster and leave fewer traces. Now to comparisons. When researchers normalize incidents by traffic volume, they find rates in this Atlantic corridor similar to other busy corridors at similar latitudes. Think of the English Channel, the Strait of Malacca, or the approaches to the Gulf of Mexico. They log many emergencies because they carry massive traffic, not because the sea there is possessed. Insurance behavior cuts through rumor. Marine underwriters and aviation insurers price risk where claims data demand it. They do not apply special surcharges simply because a route crosses the so-called triangle. If a region truly swallowed vessels at unusual rates, premiums would spike, policies would exclude it, and ports would flag the route. They haven't, which tells you how the people who pay claims see the risk. Maritime and aviation bodies classify hazards in practical terms. They mark shallow banks, reefs, storm seasons, and traffic separation schemes, but they do not designate this zone as uniquely perilous beyond normal cautions. Consider famous cases that keep the legend alive. Flight 19 in 1945 likely combined navigational confusion, poor visibility, fuel exhaustion, and radio troubles across multiple aircraft. The USS Cyclops vanished in 1918 carrying ore. Investigators cited overloading, structural stress, and a storm, all mundane and individually dangerous, especially in wartime when records ran thin. In each story, tragedy correlates with heavy use and shifting weather. That correlation doesn't cause a curse. It causes higher exposure to ordinary risks. Reporting bias does the rest. Once people expect a pattern, they collect examples that fit it and ignore ones that don't. Confirmation bias filters memory. A storm sinking near Nova Scotia becomes bad luck. But a storm sinking inside the triangle becomes evidence. Media incentives reinforce the loop. Mystery zone devours ship spreads further than routine factors plus storm sink ship, so editors favor the framing that travels. The absence of wreckage often deepens the myth. But deep water, strong currents, and time destroy evidence in many seas. Not only here. Modern tracking trims that gap. With satellite distress beacons, ADS-B for aircraft, and AIS for ships, disappearances without a trace have grown rarer since about the 1990s. Alternative explanations sometimes sound more exotic than they are. Methane hydrates, ice-like gas deposits, can reduce water density when they release. But documented releases large enough to sink big ships on the open ocean are scarce and not clustered here. Rogue waves exist, often triggered by intersecting swells or squalls. They can smash vessels anywhere, from the Agulhas Current to the North Atlantic, and they don't respect imaginary triangles. Human factors never vanish. Fatigue, maintenance shortcuts, overloading, and complacency multiply small errors into disasters, especially in crowded weather-active waters. So how do incident rates actually compare? When you group decades into rounded ranges, the per-mile accident rates in this corridor look about like rates in other high-traffic, weather-exposed routes. Numbers shift year to year because storms and economics shift traffic. The pattern stays steady. Busy seas have more events, and normalized risk stays ordinary. If this area truly had a distinct, repeatable hazard beyond known physics, we would see it replicate under controlled comparisons. We don't. The strongest pattern is exposure plus weather plus human error. Let's be fair to believers. Mystery helps us cope with grief and uncertainty. When nothing floats to the surface, we reach for a story that makes absence feel meaningful. Still, the bodies that manage risk point in one direction. Coast guards, accident boards, and insurers treat the area like any other congested ocean crossing with variable weather. What remains uncertain is not whether a curse exists, but how specific tragedies unfolded minute by minute. Some logs are incomplete, black boxes were never recovered, and currents erased clues. Uncertainty invites patience, not superstition. We can admit unknowns while refusing to invent forces we don't need. Here's a practical rule of thumb for sensational risk claims. Check the denominator, the mechanism, and the marketplace. First, denominator, ask how many safe trips pass through the area each year compared with incidents. If exposure is huge, raw counts mislead. Second, mechanism, look for a clear, testable process that would raise risk beyond normal hazards. Wind shear, current, and human error count. Curses do not. Third, marketplace. See how insurers, regulators, and operators behave with real money on the line. If premiums and classifications stay ordinary, the risk likely is too. Apply that rule beyond oceans. It works for deadly highways, haunted neighborhoods, and cursed mountains, where traffic, terrain, and weather set the odds. In short, the sea there is demanding but not damned. Weather turns fast, currents run hard, and people make mistakes, as they do anywhere ships and planes move. The distilled takeaway is simple. The so-called cursed zone doesn't swallow vessels at abnormal rates. Busy traffic, fast weather, and human factors explain the pattern. Subscribe for more myth versus reality, and tell us which enduring claim you want tested next.